Uh, Now we want to uh, introduce the binomial theorem. In the previous section, we learned about Pascal triangle. So we use Pascal triangle to expand the a plus b power n for any positive integer n. But the n is large, then it can take a long time. Combination can be used to help expand binomial expression more quickly. So uh, the phi C0 is 1, phi C1 is 5, phi C2 is 10, phi C3 is 10, phi C4 is 5, phi C5 is 1. Okay, so we look at this. The Pascal triangle, we have this 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and the 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. So this one is same with this one. So you see, we have the phi C0 is 1, and then phi C1 is 5, phi C2 is 10, phi C3 is 10 as well, phi C4 is 5, and phi C5 is 1. So it's same with the value here. So the a plus b power 5 we can write as phi C0 a power 5, phi C1 a power 4, phi C2 a power 3, phi C3 a power 2, phi C4 a power 1, phi C5. And then the b power 5, b power 4, b power 3, b power 2, b power 1, and no b here. So this one we can generally write as the NC0 a power n, NC1 a power n minus 1 b power 1, and then NC2 a power n minus 2 b power 2, NC3 a n minus 3 b power 3, and so on until the last one is the NCn b power n. So in general, it is the NCR, okay, NCR a power n minus r b power r. Okay, so NCR a power n minus r b power r. But NC0 is 1 and NCn also 1. So any number C0, okay, like 5C5 is 1, and the 5C0 also 1. Any number like we have 15C0 is also 1. And then we have the 15C15 also 1. So this one they simplify until this. But I will prefer use this, okay, because we can uh, uh, see a pattern there, okay, compared to this one. So the NC1 we also can write in this form. Okay, this one, the NCR we also can write an NR, but I will prefer to write the NCR lah. So these formula are known as the binomial theorem. Okay, we look at this book example number 3. We want to use the binomial theorem to expand this one. So uh, n is 5. So we have 5C0, 5C1, 5C2, 5C3, 5C, 5C2, 5C3, 5C4, and 5C5. Then we have the 3 power 5, 4, 3, 2, 1, don't have 3. 4x power 5, 4, 3, 2, 1. So we will have this one as the 5C0, 3 to the power 5, 5C, 5C0, 3 to the power 5, 2, 4, 3. Okay. And then plus the 5C1, 3 to the power 4, and then 4 to the power 1. Then 1620x. And then we have the 5c2, 3 to the power 3. And then 4 square, 4320x squared. And then 5c3, 3 square, 4 cube, 5760 x cube. And then we have the 5c4, 3 to the power 1, 4 to the power 4, then 3840. And we have the 5c5, 3 to the power of 0, 4 to the power 5, 1024 x power 5. This one actually we can use Pascal triangle 1 5 10 10 5 1, okay, to solve it. But normally we will use the normally we will use the uh binomial expansion instead of the Pascal triangle. Okay, so for this one, if you want to use the Pascal triangle, then we have the 1 5 10 10 5 1, then 3 power 5, 3 power 4, 3 power 3, 3 power 2, 3 power 1, and then no 3 here, 4x power 5, 4x power 4, and then 4x power 3, and 4x power 2, and 4x. Okay, so we have 243 plus this one we have 5 times 3 power 4, and then times 4, 1620 x, and then we have the 10 times 3 power 3 times 4 square, then it's 4320 x square, and then we have the 10 times 3 square times 4 cube. Okay, 5760 x cube. And then we have the 5 times 3 times 4 to the power 4, then 3840 x power 4, and then this one is 4 power 5, 1024 x power 5. We can use either one, but normally we will use the binomial expansion. After we learn binomial expansion, we don't use Pascal triangle anymore. We look at work example number 4. We want to find the coefficient of x power 20 in the expansion of this one. So 20, then we have something until the 25c20, and then 2 to the power of 5, negative x to the power 20. Then we have the 25c20 times 2 power 5, and then multiply with the negative 1 to the power of 20 will be this. And then x power 20. So the coefficient of 20 is 1700160. Okay, this one if you want to do the Pascal triangle will be very difficult until 25. Oh, not easy man, a lot. If we use binomial theorem for the 1 plus x power 7, then we have the 1 power 7, 7c1, 1 power 6, 1 power 5, 1 power 4, 1 power 3, and so on. And we can see that actually this one, the 1 power something is still 1. And then the 7C1 is this 7 factorial. Okay, we know that the NCR, the definition of NCR is the n factorial, r factorial, n minus r factorial. So the 7C1 will be 7 factorial, 1 factorial, 7 minus 1 factorial. So this one is actually 7 factorial over the 6 factorial. 7 factorial we can write as 7 times 6 factorial and then divide by the 6 factorial. Then cancel, we will have 7 here. Okay, and then if we want to find the 7C2, okay, we observe the pattern 7C2, then it will be the 7 factorial, 2 factorial, 7 minus 2 factorial. Then is 7 times 6 times 5 factorial over the 2 factorial times 5 factorial. So the 5 factorial cancel with the 5 factorial. Then we have the 7 times 6 over 2 factorial. And then we have the 7C3. Then it will be 7 factorial, 3 factorial, 7 minus 3, which is 4 factorial. Then we have the 7, 6, 5, 4 factorial. And then 3 factorial multiplied with the 4 factorial. And this one can be cancelled. And we have the 7C4, which is 7 factorial, 4 factorial, 7 minus 4 factorial, which is 3 factorial. Then 7, 6, 5, 4, 3 factorial over the 4 factorial times the 3 factorial. So this one cancel. So this lead to alternative formula for binomial expansion. So you can see 7 is the n. Okay, and then the next one is the 7, 6, 2 factorial, 7, 6, 5, 3 factorial, 7, 6, 5, 4, 4 factorial. Okay, so 1 plus n, 1 plus n, 1 plus x power n, we can write as 1 plus nx, n minus 1 over 2 factorial, x squared, n minus 1, n minus 2, 3 factorial, n cubed, n minus 1, n minus 2, n minus 3 over 4 factorial, x power 4. Okay, this one with a condition, we can use this if only we can, this one, this must be 1. Okay, if it is not 1, then we have to use the previous formula. Only it is 1, then only we can use this formula. Next, we want to find the first 4 terms. For the A, we can straight using the new method that we found before this. So we have the 1 and then plus 7 times 3y plus 7, 6 over 2 factorial and then 3y squared, 7, 6, 5 and then 3 factorial, 3y power 3. Okay, then it will be 1 plus 21y plus this one we have the 7 times 6 divided by 2 times 3 squared, then it's 189 y squared. And then we have the 7 times 6 times 5 divided by 3 factorial times 3 power 3, then 945 y power 3 and so on. Okay, so this one is the n, and then x, this one is the n minus 1, 2 factorial, this is the x squared over 2 factorial. Then we have the n minus 1, n minus 2, 3 factorial, x power 3. And the x here is the 3y. For this one next, it is not, this one is not 1. Then normally for this one, I will not use the binomial expansion. Okay, the simplified binomial expansion. For this one, I will just use the uh, NC1. Okay, wait. This one, if I do this, then I will have 6C0, 6C1, 6C2, 6C3, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, and 2 to the power of 3. And then we have the negative y to the power 0, negative y to the power 1, negative y to the power 2, negative y to the power 3. Then this is equal to 1, 1, 2 to the power 6, 2, 4, 8, 16, 32, 64, 64. And then plus this one is the 6C1 times 2 to the power 5. And then this one is 192 minus 192y. Okay, negative 1. And then 6C2 and 2 to the power 4. Then we have 240y squared. And then minus and 6C3, 2 to the power 3. Then it's 160y cubed. Then this is the final answer. So I will do it this way. But the textbook here, what they do is they are doing this way. Okay, they want to use the simplified version. Okay, maybe they don't want to use calculator lah. So they factorize the 2, then y minus y over 2, and then power 6. Then we have 2 power 6, and this one is 2 power 6, 1 minus y over 2 power 6. Then we have the 1 plus 6 negative y over 2 plus 6, 5, 2 factorial negative y over 2 square, 6, 5, 6, 5, 4, 2. This one is 3 factorial, 1, 0, 1, 2, 3 factorial, negative y over 2 power 3. Okay, then we have the 2 power 6. So 2 power 6, 2 power 6, and then 1 minus 3y, and then plus uh, this is divide 15. So we have the 15y square over 2 square, and then minus this one 3 times 2, 6, cancel 20, and then no, we have 5, and then divide this one 5 over 2, y power 3. Then 2 power 6, we have 2, 4, 2, 4, 8, 16, 32, 64. So we have 64. This one is actually 64. Then only we multiply inside this one. So minus the 3, 4, then 12, 192, 1. And then plus this one, divide by 4, 16, 16 times 15. 16 times 15, suppose we can calculate by ourselves, but I use calculator, 240y squared. And then this one divide, then 32 times 5. 32 times 5, then is 160 y cubed. Okay, we'll get the same answer also. But I don't do it this way. I will do the first way. Okay, this one B. Okay, I will use the normal binomial. The one will be far more easier.